the latest on what's going on with our receiver and where the status is of that is. So, Ken, if you're ready.
Yeah, I'm ready to go. I just wanted to say something. I was at the club meeting last night. I made an announcement that we're having this presentation tonight, and just looking at the list, nobody's here from the meeting. So all those members, exclude them from joining the buildathon.
Looks that way.
Yeah. So anyways, yeah, I'm ready to go. Okay, I got to share my screen. Where the heck is it? Entire screen. So if I use entire screen, I have to have everything open, right?
Yeah.
Okay, I think I've got it all go. Okay, let me just... Okay, can you guys see that?
Well, we can see all of us.
Yep.
There we go.
I can see it perfectly. Great.
Okay, good. Okay, so this is version 2 of the DCR. And this is just a prototype, so it was milled by Kelly. And if we go around the edge of the board, we can see at the top left, we've got the speaker plug, power plug, antenna, external VFO, so you could use your PARC SigGen for this. I've got a couple videos, and one of them is using this with the SigGen. We've got a plug-in VFO. So currently I have a 40 and a 20 meter VFO. The SA612 there to the left of the VFO board. At the bottom there from the left is the volume. The middle one's the fine tune, and the right one's the coarse tune. And on the left side, we've got the LM386. And we've got a plug-in BPF, or a bandpass filter. So this is the current state. Both bands are working. I have one issue, but I'll discuss that near the end. Okay, so let's see what else we have. Okay, here's the schematic for the DCR. So on top left there, we've got the power in, reverse direction diode through. We've got a 12-volt pickoff and a 6-volt regulator. The 6-volt regulator feeds the SA612, and the 12 volts feeds everything else. Down on this corner, we've got the antenna coming in, and it's going directly into the bandpass filter. This bandpass filter is the exact size and header spacing as the what's his name's bandpass filters.
QRP Labs.
Yeah, QRP Labs. So the QRP Labs will fit the headers. You'll just have to modify the output toroid to work with the input of the 612. Then we've got, so we've got it coming in pin 1, pin 2 is the ground. I'm thinking about putting a header here so that we could have a balanced input. So that means the output will be to both pins 1 and 2. And the upside of that is less noise. So I'll be talking to Kelly about that. Off pin 4, we've got the audio bandpass coming through, little filter, volume control into LM386, and then out to the speaker plug. On the right side here, SMA, this is where you would plug in your SigGen. I've got an attenuator to bring it down. Now, the specs for the 612 say that the peak-to-peak input should be between 200 and 300 millivolts. After talking to Diz at kits and parts, he's actually analyzed and this chip, and 200 to 300 millivolts peak to peak is not strong enough. So he also has a DCR kit, and he's got it set up so that it's driving pin 6 at 700 millivolts. So this attenuator is set up to get about 700 out. You can select between the SIGGEN input and the analog VFO via a jumper here. And when you select the SIGGEN, the jumper is on these 2 pins and it feeds into pin 6. When the jumper is over at the VFO, the VFO is now active. Oh, by the way, if you're going to use the SIGGEN, I would recommend unplugging the VFO because you might get stray signals from it. With the VFO, it's going to have the fine tune and the coarse tune. Now, there's one issue with, let me see if I have it here. Yeah. Excuse me. This VFO is very sensitive to touch. Even if you bring your hand close by, it's going to detune the oscillator. Even if you try to scope the 612 to get a frequency off of it, the VFO shifts. I have I don't know if you can see it here, there's a header here. This was going to be the future input for a future frequency counter. So if you don't have a PARC SIGGEN, then there would be a header that you can plug in and then you can get the frequency off of that. This area here is a big issue. Even if you bring in a wire close by to pick up some of the voltage, it changes the frequency. If I try and scope pin 6, the capacitance of the scope probe is shifting the frequency. Now, on pin 7, it has hardly any effect whatsoever. But because you're in this general area with your hand and the scope probe and wires, it's still shifting it. So what I am trying out right now is this little circuit. I got this little circuit off another DCR kit. I'm just putting it together now. So what's going to happen is instead of coming off of pin 6, it's going to come off of pin 7 through a light load capacitor, and it's going to buffer it, and we've got a place that you could hook your probe up to. So I'm going to be trying that out this weekend and see how this works. So far, any questions?
Yeah, I have a couple.
Yeah, if Pete, if some people are putting, I can't see hands going up, so if you could keep track of who's got their hand up.
Yes, I will.
Thank you.
Okay.
Peter, you muted.
Okay, I thought I unmuted. Okay, the bandpass filter, you mentioned that you have to rework the toroid. So you cannot insert the QRP Labs BPF directly. You have to rework the output toroid somewhat, Ken?
Yeah, the QRP Labs is 50 in, 50 out. The SA612 is 1,300 ohms per pin.
All right, okay.
Okay, so if you wanted to use a QRP Labs filter, then you would have to rework the output toroid,
Okay.
or you can change the capacitors to
Okay.
change the impedance.
Okay, and one other, I'll make one comment. We don't need to address it right at this particular moment, but the SIGGEN output, we talked 7 dBm, but we're having a bit of a conversation. We're finding that maybe not quite so. So maybe somewhere along the way, not necessarily this meeting, maybe the next or somewhere, I'd like to address the output of the SIGGEN.
Okay.
Hassan, you got a question?
Yeah, I can't see what the 3904 at the top right. What's it for? Is it just a simple buffer?
It's just going to be a buffer.
What's the 10K resistor for on the bottom, the emitter?
Just as a load.
Okay. Maybe I've been staring at MOSFET circuits for so long, I can't remember why we need that.
Yeah, it's just if you don't have this load on here, you get strictly current coming through to the output. This will place a voltage on the resistor, and then you could read it off the output. I'm not saying this is going to work. I want to try it out, but I noticed on a couple of other DCR kits that are available from around the world, this is how they're doing it. QRP guys also has a DCR, and what they did was, I didn't want to show this yet. Okay, so here's the VFO. What they did was, this is the toroid for the frequency and the capacitor. What they did is they put a two turns around this toroid to use as an output to measure with a digital dial or a scope. Unfortunately, if you bring anything even close, remotely close to that toroid, the frequency shifts.
Oh, just hooking up test equipment would cause it to shift.
Yeah, yeah.
So we do need a buffer then.
Yeah, so that's what I'm hoping this is going to happen with this. Pin 7 is not as bad as pin 6 is, but just bringing your hand or a scope probe or a wire in the general area is causing the VFO to shift. And it's a real pain in the arse.
Are six is an input and 7's an output?
Well, no, they're both inputs. It's a, I think it's a Colpitts oscillator. So the transistor for the oscillator is on the chip. These two capacitors and the resistor are on the emitter of the transistor on the inside of the 612.
So the 3904 does it have to amplify the signal at all?
Excuse me?
On this buffer you have, transistor Q, does it have to amplify the signal?
No, not necessarily. It could be unity.
Okay, I'm just wondering, why don't you just pipe it to a CMOS gate and get a digital square wave output for your frequency counter?
Yeah, I could probably do that too.
That's a good idea.
Yeah, that's a good idea.
Yeah, just a hex inverter or something like an inverter chip, and set a threshold or something, bias it or whatever, and that should take care of it.
How high is the voltage?
I don't recall offhand. A few volts, I think.
I think a CMOS is not going to trigger.
Yeah.
Why not? They can trigger it at 1.3 volts, as low as you want. You can get CMOS, and it should, and it's just got to be. You can bias the CMOS at like the halfway point, I think, and then anything above and below just causes it to go. So you don't need a full swing input. It just has to be above VCC over 2 or below VCC over 2.
Well, in this case, I've got to hook up to 6 volts.
Mm-hmm. Yeah.
Anyways,
is this oscillator plus or minus or a thing? What's that? Is the oscillator plus or minus dual polarity or single ended?
Single.
So it's probably a square wave then.
Mm-hmm.
Yeah.
You should check that out, because I mean, if it was a sine wave, it would be dual polarity. If it's single ended, it's probably a square wave to begin with. in which case
Yeah.
it's even easier to deal with.
Yeah, well, I got some investigating to do. I want people to have the ability to know what frequencies they're dialing in. And as it is right now, it's very hard to do. What I'm doing is I have a soft rock ensemble version 9 that I bought off of Tony years ago. And what I mostly use it for is to check WWVCHU, and I also have a what do you call it? A GPS gadget that I do for calibrating. And what I've been doing to measure it is just have a wire loosely underneath the board plugged into the soft rock, and it picks up a signal, and I can see that on in the HD SDR window, the FFT. So that way I'm checking what the frequency is at.
Okay. Dave, I know you had your hand up a while back. Do you still have a question, or has it already been taken care of?
Peter, you asked every single question I was going to ask about the
well, great minds, buddy. Great minds.
Yeah, I was going to ask about the impedance matching for the bandpass filter.
Yeah.
And I was going to ask about that attenuator for the SIGGEN, because I suggested that you have a conversation with Michael, because I think Michael's done a lot of research, a lot of measurements in terms of what's going on there.
Yeah, my the PARC SIGGEN for me is in, I won't say it's in pieces, but it's not serviceable at the moment, so I can't make my own measurements. So if anybody here has done the PARC SIGGEN, it'd be great if you could make some output measurements for us to see if you're getting the same kind of results that Michael's getting. And speaking of Michael, he has his hand up.
Yeah, I wasn't gonna go into the weeds, and I'm not gonna. But for what it's worth, I'm seeing 11 dBm out of my signal generator, and I don't know why. I think it's got to do with the fact that it's a square wave versus a sine wave. I don't know. That's for another time. But I had the 2N3904. I take it the biasing is the 100K resistor and the 10K resistor, I presume.
Yeah.
If the SA612 puts out a square wave offset from 0, which I think is what you're saying, so it's a DC, then the capacitor, that 10 picofarad capacitor, would turn it into a plus and minus square wave, wouldn't it?
The output at pin 6 and 7 is a sine wave.
Oh, okay. So it's going to be a sine wave when it arrives at the base of the transistor then.
Yeah.
Right. And the idea is that a transistor just doesn't, by putting the transistor in, you don't load down the oscillator. Is that what it's for?
Yeah. Yeah.
Okay. What else was I going to ask? Yeah. Okay. That's okay. That's good to know. Thank you.
Okay, Dave, hands up again.
Yeah, I just wanted to, Michael,
Yeah.
was poking around my shack this week. I couldn't get my SIGGEN to work because it's got the code loaded for the dueling 612, the D612, because I repurposed it. But I did find this. I don't know if you could see this.
Yeah.
This is the original SIGGEN I built, and then the PARC SIGGEN was modeled after this. It's exactly the same circuit. Now look at the writing I've got. Can you see that?
No, not really.
Okay, it says 12 dBm.
Aha.
And then if you look down here, there's another port here.
Yeah.
Okay, that port says 7 dBm, and I put an attenuator.
On the prototype.
Yes, well, it wasn't a prototype. This wasn't a prototype for PARC. I built this years and years and years ago as my signal generator, because I was using this for my PSK transceiver, and so I needed something that was a lot less hotter, And so I put a pad in to take it down, and it says 7 dBm there. So I think you're absolutely right with your measurements, because all these ports are saying it's 12 dBm.
Okay.
I don't understand. Like, I don't understand how we missed that, because when we were doing the prototyping for this, we must have had what, 1, 2, 3, about 4 of them out there making measurements, and that nobody picked up that we were putting more out than 7 dBm.
It's very convenient, actually. If you assume the output from the signal generator is a sine wave, then you take the voltage you get off your scope, the RMS voltage, and you divide it by or multiply it by 0.707, and that takes you from 11 to 7 dBm. It so happens. So I don't know. I'd love to talk about this later, but now isn't the time.
Maybe we'll do it as an agenda item somewhere along the way, but next month or something, but our next meeting. But okay, Hassan, you got a question?
Yeah. If we look back at the thing on the diagram, I just realized after Michael said that there's that capacitor there. So you're going to have dual polarity sine wave coming into the Q transistor, and this transistor will only amplify positive pulses. So it's going to
Why?
Because it doesn't have a bias, and it's not. Yeah, it doesn't have a bias.
Well, it does. Well, I don't know. The 100K and the 10K resistor provide base bias, right?
That's true, but the signal swing has to be then much less than 6
Yeah,
volts.
there's no resistor between the collector and the plus 6 volts. That's right. I guess that's what you're saying.
I'm too tired to actually fully analyze it, but I can just see that it's not. It seems like a single-ended amplifier, and it doesn't. I can't see how it's going to work with double.
Well, like I said before, I pulled it off of 2 existing kits that are on the market and have been for a while. I haven't tried it yet. I'm just putting a little scrap together, and I'm going to try it out.
Yeah, because what happens is you can distort frequency waveforms horrendously bad, and as long as the frequency doesn't change, it's fine.
Yeah, that's what I'm looking for.
Yeah, okay.
Prove that you can have a really crappy signal and you can still count the frequency or count it. So.
Yeah. What's the point of tuning it with the coarse and fine controls when you don't even know what frequency you're on?
Yeah.
So we need some way of measuring it.
It'll be interesting to see what you come up with here on this one. That's for sure.
So could you put a commercial frequency counter on J7?
You should
happen to have one. I'm just asking.
Yeah, you should be able to. You might have to build up an external amplifier or something. I don't know yet. I have to. Once I get this built, I'm going to take some measurements. The 2 kits that are using that circuit, that transistor, they're both hanging a 50 ohm load on the output and then putting their scope on it.
Mm-hmm.
Okay, Wayne's got a question here as well. Go ahead, Wayne.
Sorry, I had myself on mute. I'm thinking that the sine wave coming out of that is offset by half of VCC coming off the 6112. I don't think it drops below 0.
Oh, possibly. I haven't done any final measurements on this thing. I've been trying to get it to work.
Gee, LT Spice would come in handy here.
I was just going to say, can you simulate an SA612 in LT Spice? I guess so.
Yeah, you do. There's models out there.
That's why I've had to have my hand up. I was going to suggest modeling this in LT Spice. I do have a model of an SA612, and it works pretty good.
I'm going to do that. That'll be fun.
Oh, and speaking of Dave, Dave, you had a question as well?
That was my question. It was about LT Spice.
Oh, if someone wants to do it on their own.
I'll do it.
Okay, go ahead.
Just out of interest, just to see.
Share the model of that sometime this week, Dave.
There's 2 good ones that I've been Googling around. Apparently, they work quite well.
For the SL612.
Yeah.
Oh, yeah.
Okay, is there any other questions? Okay, Ken, carry on.
Okay, so at the top here, we've got the bandpass filter. This is very, it's using a voltage dividing capacitors here. This circuit is very, very common with any kit that is using this SA612. And basically what it's doing is it's taking your 50 ohm load on the input and pumping out 1300 per pin. If we wanted a balanced output, then this ground would come off and this would go to pin 2 on the SA612. Of course, the output of this has got to be at 2600 ohms. I have both bandpass filters for 40 and 20. I've put it through the PARC SNA. They work quite well. They're a little wide, but if anybody wants to venture into beefing this one up or putting a 2 or 3 pole or 5 pole filter on the front of it, then you can give that a try. What I'm trying to do is keep this as simple as possible and as inexpensive as possible for everybody to join in. And if you want to experiment with this, go right ahead. A lot of the kits are using this configuration on the input to the SA612, and a lot of them are putting a 3 pole or 5 pole 50 ohm filter ahead of it. So basically what this is doing, it's doing an impedance match from 50 to 1300 per pin.
And the C2 is, and C1 is doing that, or something's.
Yes.
Well, the whole combination of the whole thing, because if you didn't have C2, you just have a basic filter, wouldn't you?
Yeah, but you wouldn't get the impedance matching.
Yeah.
So I've built up both the 40 and 20. They both work. Like I said, they on the SNA, they're a little wide. I think they're like 800 kilohertz, but they do work. They do work quite well. And my anticipation, my thoughts are, we're going to supply 2 boards, one for 40, one for 20, and 2 additional blank ones that you guys can experiment with.
And the NPO, that's a high accuracy capacitor, isn't it? That's what that means.
NPO, yeah. So down here, here's the VFO. They're all built for the same way. The only difference between the bands is the toroid itself, how many windings. So you can see here, everything's the same. On 40, the toroid's 4.7 microhenries, and on 20, it's 1.5. I have to verify these turns on here, but they do work. Works quite well, as long as you keep your hands away from it. I was thinking
So Ken, I was going to say in that case, then a digital pot would be perfect for R10 then.
Yeah, it would be. Well, the way I've got it set up here, you can see by here, even if I try and tune this, it has no effect on the VFO whatsoever. And plus the knobs are plastic. And this little wire here, it's just there to measure the DC voltage on the input of the VFO.
Ken, you were talking about the bandpass filter and adding additional components there for that's a pretty tight filter. That'd be a pretty tough thing to do, I think. Difficult space I'm referring to.
Well, you could, if you want, say for your example, you want to use the QRP labs. What you can do is piggyback a smaller board with this impedance matching setup here.
Ken?
Yeah.
Just out of curiosity, how did you do the diagrams? Is that software package or something that does that?
Yeah, it's what's it called? Oh, I forget the name of it. I've been using it for years. And it's free.
Abigrin?
Pardon?
Sorry, what was it called?
I'm trying to remember the name and I can't think of it.
I'll email you and ask you. Okay, thanks.
Yeah. I actually like it. It works really nice. It's got a library of all the popular parts, name brands. It's got a lot of generic stuff. You know, it's got the popular transistors 3906, 3904.
Good.
So,
Right.
yeah, so that's so what's happening is this is the output going to pin 6 on the SA612, and basically what's happening through the fine tune and coarse tune, we're varying the voltage on this pin, essentially, which is changing the reverse voltage on the diode. By changing the DC level on the cathode in reverse direction, it does vary the capacitance.
Right. Okay.
And it turns out that the one in 4004 has the biggest capacitance variance out of the common diodes. 4001, 4002, 4003 is quite low, but the 4004 works out quite well. This variable resistor here is just a multi-turn pot, and it's for calibrating the band edges. So through this coarse tune and this resistor here, we could set the lower end of the band and set the upper end of the band. But if you want to make it wider, you know, like say you want to go to 6.5 up to, I don't know, 7.5 or 8, you can do it. So that's what's that?
Nope, nothing.
Oh, okay. So any other questions while I've got this up?
Yeah, Ken, why on the VFO you've got, and likewise the bandpass filter, you've got pins 1 and 2 and the input and the output joined together. Why is that again?
What we're gonna do is for pin 1 on both sides, what you do is on the actual male connector is cut the pins off and stick them into the female pin 1, so that if you take this board out and reverse it, it won't plug in.
Oh, okay, sure.
And we'll be doing the same thing with the bandpass filter.
So it's a safety thing.
Yeah, it's a safety thing. For the bandpass filter, there's no DC involved. Even if you put it in reverse, it's not really going to affect anything. But because of the VFO having 6 volts coming in and reversing it, you're basically going to shorting things out. So what I've learned from Kelly was take both pins, 1 male ends, cut them out, cut them off, and stick them into the female connector. And then if you happen to reverse the VFO, it won't plug in.
Oh, that's a good idea.
Yeah.
Any other questions? Okay, no questions, Dave. Ken.
Okay, so I got a couple of videos. Let's see here. Guys, see that?
Yeah.
Okay. I hope the audio works out. I filmed this with my my phone, so the quality's not that great. This is the SIG-Gen with the DCR with the SIG-Gen for a VFO. So you'll notice the VFO is unplugged. And here's a jumper for choosing between the SIG-Gen and the VFO. I've got it set to SIG-Gen right now. Can you guys hear the volume?
No,
Oh, you can't.
I can't anyway.
Are you hearing the volume, Ken?
I've got the volume up.
Ken, you may need to share your audio.
Okay. How do I do that? How do I share my audio?
Oh, click open share your screen. At the bottom left-hand corner of the window, there's a little box there that you check for share system audio.
Okay, I stopped sharing, period.
So go back into the share screen.
Share, yeah.
Okay, bottom left-hand corner of the window, it says there's a box there.
Oh, there it is. Okay, okay.
I learned something new.
Okay, you guys see that?
Yep, you can see it.
ECR. Right now, I've got
And we can hear you.
SIGGEN plugged in as the VFO. I've got the 40-meter VFO pulled out, and there's a jumper there to switch between the VFO and the SIGGEN. And that's what version 2 of the prototype looks like. I've got the SIGGEN hooked up right now. So here's some CW. See if we can find some PSK or whatever you call it. There's some side down. And you can hear a shortwave station in the background.
I think it was you that did that. The guy with the voice that sounds like. Nothing like that. Nothing like the dude. You got the big boy one?
So that's the DCR working with the PARC SIGGEN.
Cool. Okay, so how do I get out of this? Okay, I got one more video. Let me load it up.
What's that?
Where is... Guys see that?
No, not yet. Just see you. Oh, there it is. Yeah.
Okay. So now this is the DCR with a 40-meter VFO in there.
Okay, so I've got the setup now where I've taken the SIGGEN off and I'm using a 40 meter VFO. And what you hear in the background is shortwave. I think it's up around 7.200, somewhere around there. So let's see if we can find some SSB or CW signals. That's another shortwave station. Here's some SSB.
It's not going to be a real great day. It's going to rain on us.
There's some CW in the background now. So this is the DCR setup with a 40 meter VFO.
Cool.
Okay. Oh, got a few questions here. At least one, anyways. Hassan, go ahead.
Yeah, I was wondering if you detune the radio when you put your hand on the tuning knob.
No, the plastic.
But even like on my regen, it kind of, it's so sensitive that, you know, if you even touch it, it's kind of tricky. I'm wondering if there's like no effect whatsoever.
None whatsoever. I've checked it over and over. I've even touched the ground plane of the board, and nothing changes.
And what's that? It's tuning a pot, right?
Yeah, yeah.
So do you have a fine control as well as a coarse control?
Yes. Let me. Where am I? Share. See my screen?
Yep.
Okay, got fine tune right here, which would be the middle one, and a coarse tune one, which is the right one. So if we go back here, so we got fine tune right here, and coarse tune right here.
Is that going to work? I mean, the coarse tune is 1K, and the fine tune, you'll have different fine. I'll send you another circuit that actually solves it in a different way, but because I think the way you have it there, there'll be nothing consistent between the two. If coarse tune is down at 1K, fine tune is not fine tune anymore.
Yeah, so
there's a circuit that gets around that problem. I'll see if I can dig it up.
Okay, I want to make a statement right now. This is not a high-end commercial receiver. This is strictly an inexpensive experimental receiver that you guys can play with.
I understand, but if just one or two more resistors, you can get what you want. So,
well, you can send me an email. I could try it out, but what I'm trying to avoid is having to redesign the board.
I see.
You know, we've been Frank and I have been working on this for 2 years now. Mostly Frank in the first year, and then when he moved, I took it over last spring, and all I've been doing is working on this project to get it done. I want to get this thing out sometime this summer.
Okay.
Frank has spent a lot of time on it. I've spent a lot of time on it. And to be honest with you, I'm sick and tired of looking at this thing.
All right.
But you know what? On the positive side, I think it works good, and I think the results are good. If you go buy a QRP Guys DCR or one of the other ones, you're going to get the same results because they're all basically built the same way.
Mm-hmm.
I even bought a, what was it, about 4 years ago? There's this one-man company somewhere in Europe, and he came up with his own version of the DCR kit. And that's where that buffer, 3904 buffer circuit came from. So, and then apparently this guy has sold a lot of them. So I'd like to try it out and see if it solves the problem.
I think it's working pretty good the way it is there as well, Ken. So, we got another question here. Frank, go ahead.
Yeah, just a comment to Ken there that I think you've done a fantastic job. Like you say, I was involved in it in the early stages, and it looks like it's coming along beautifully. And congratulations on the work that you've done. It should be a fantastic build-a-thon.
Yeah, thank you. Yeah, like I said, I think we're just about at the point that I can say, Kelly, order these boards.
Right.
And I also have had a bill of materials logged in at DigiKey for about a year now. Okay, once a month I'll go in and check the pricing, and every month they keep going up and up. You know, like you were paying 50 cents for a capacitor, you're now paying like 80 cents now. So as time goes on, the price is going up.
Yeah. Okay. You got another question, Frank, or is your hand just still up?
No.
Okay. Okay, I think that's it. There isn't any more comments or questions?
Other than to say it's really neat, and I'm going to try to simulate an LT spice just for fun.
Yeah, I'd be interested to see what your results are.
Yeah, that'll be really good, Michael. I'm not sure if I have a model for the 612 or not, but I'll take a look. If not, I know somebody who has one, right, Dave? Okay. If any other comments? Okay.
Okay, so there will be an announcement sometime down the road in the next, well, I don't know, 2 months.
Well, this is June. Yeah.
Yeah, June, a couple months. I think, like I said, we're almost at the point where I can say Kelly ordered the boards. The kit's going to contain the motherboard, and they're going to contain 4 bandpass filters and parts for 2 of them, and you'll have 2 spares that you can play with, and same thing goes with the VFO. And hope everybody has fun with it. You know, like I've been looking at for so long that I'm sick of it, but you know what? The results are enjoyable. The other thing is, if you notice, I had to keep turning up the volume. I'm using an end fed, and it's a very narrow bandwidth on it. So, yeah, hopefully this summer I'm going to get my dipoles up and solve that problem. And I think Wayne, he wants to try some CW filters on in place of the 386, piggyback it or something.
Oh, okay.
That's great. Yeah.
Well, that's very good, Ken. Thank you for all the work you put into this, and Frank as well. I'm looking forward to doing that. It's a nice little platform to experiment with. In the back of my head, I got some audio circuit. I'm thinking about maybe it might be nice to play around with as well on that. And that's what the whole idea of this particular project was anyways, was to experiment around with the different parts of the circuit. Okay, I'll send you an email, Ken. I just have a couple of questions for Kelly, but I'll send you an email for that.
Yeah, we got to call Kelly. He doesn't respond to emails.
Okay. Okay, I'll give you the question. So I'll send you the email anyway.
Yeah.
Okay. Is that it, Ken? I think you pretty much covered off everything.
Yep. Yeah.
Okay. Okay. Thank you very much, Ken.
I'll keep everybody up to date with this buffer circuit and see if it
Yeah.
works.
Yeah, put it on the group's IO or something, and then we can.
Yeah, I will.
Okay. Up next, I guess, Dave, you ready to go with the Wheatstone Bridge?
Sure. Yeah, I'm just wondering. It's 8:30 now. I'm gonna need about 20 minutes. How long
That's
does
fine.
Wayne need?
Oh, that's fine.
Wayne, how much time do you need for your segment?
5 minutes, 2 minutes. You're still muted, Wayne.
10 minutes, sorry.
Okay, so
Am I
I'll
still
go.
muted now?
Yeah, I'm about 15, 20 minutes or so. It's not a long presentation by any means, but let me get going here. Okay, where do I share my screen?
We should be all pros at sharing screens by now.
I know, it's terrible. Okay, there, can you guys see my screen?
Yeah.
No,
Good, but there we go.
I don't
Okay.
see it. I don't see it.
Can everyone see my screen?
Yes,
Yep.
we can.
Yeah, there it is. Yeah.
Okay, so very good. Let me get going. So I'm going to be talking about what a load cell is, and that leads into talk about Wheatstone bridges. So, just what I'm going to do is why I'm doing this, what a Wheatstone is, what load cell strain gauges are. I've got some measurements and some simulations, and then I'll talk about how to use a Wheatstone bridge for measuring SWR. So again, it's my classic disclaimer. I'm not a guru on this. This is something I did out of need, and it's not a tutorial. It's more of a log. And I'll quote Charlie Morris. This is a log of my journey, right or wrong. So, if I misstate anything, don't hold me to it. I'm not an engineer. So how I started, doing this, because I crashed a lot of airplanes and helis and stuff, and some of it was due to the aircraft being underpowered. So what I needed to do was to be able to measure the thrust of a propeller on a airplane to make sure the airplane wasn't underpowered and it won't crash. So I had to build this thrust measurement bench. And in the end, this is what the final product looked like. So here I've got two types of measuring stations. One here, you can see the motor attached, a propeller. This is my controller to control the speed of the propeller and also measure the current draw and wattage consumed by the motor. This black box here, it's actually in a printed, 3D printed case, and it's basically a scale. All it is just a scale, just your standard digital scale, except I built it out of an Arduino and 2x20 display, or 2x16. I can't remember if it's 16 or 20 display. And both of these use something called a load cell. And here you could see the load cell there, and you can see the load cell there. And that's used to measure the weight, the thrust that these motors are, with the propellers are generating. So before I start talking about the load cell, we need to talk a little bit about a Wheatstone bridge. I believe probably you guys will know what this is and probably know a lot more than me about a Wheatstone bridge. But basically all it is, it's 4 resistors similar to a full bridge diode. So when I look at this, it's basically the same as a full bridge diode or a full bridge rectifier. So in this case, you've got 4 resistors connected in this fashion. You feed a voltage in at 2 points. And then, so if I feed a voltage here with respect to ground here, that's my V in. Then this point is a voltage divider because R1 and R2 forms a voltage divider. And then R2 and R4 forms a voltage divider here. Can you guys hear me okay?
Yeah.
Okay.
Yeah, no
Okay, so it forms a voltage divider. And if all 4 of these resistors are the same, the voltage across here would be 0. because if they're all the same, this point would be half the voltage of here. If R2 and R4 are the same, it's a voltage divider. This voltage will be half. And if R1 and R3 is the same voltage as R2 and R4, that's also voltage divider here. That'll be half. And the voltage difference across here is 0. So that's what a Wheatstone bridge is. And here's a classic case of using a Wheatstone bridge where you've got an unknown resistor and you're trying to figure out what that resistance is. You know, you would have a variable resistor here, tune this resistor until the voltage across the bridge is 0. Once that voltage there is 0, then you know R2 has to be equal to Rx. Now, one of the reasons you would do this to measure Rx is that this is temperature tolerant. If I was to take, this was a very small resistance I'm measuring, and I use an ohm meter to go and measure it, or I pass, you know, a current through it and I measure the voltage. If this, depending on temperature, this might change and you may not be able to get a fairly precise reading of Rx. But in this fashion, all the resistors will be affected by temperature in the same way. And so you're getting a little bit of temperature tolerance. So I've got a little video here I made showing some measurements I made. And let me just hide this. Okay, and this diagram here is just I can be referring to it. So here's the load cell I'm using. It's called a 4-beam, a 4-wire shear, because it's like a shear, you know, like a pair of scissors. You're shearing, so you're trying to shear this point here by applying weight to one side and not the other side. The other side stationary. This side has a weight, so it's a shear across here. And so you're measuring the shear, and it uses 4 wires. So the way the 4 wires work is red and black are power. Here, the excitation. You see, here's your bridge, because this is actually a bridge. So it's got, this forms a Wheatstone bridge, right? That's embedded in the load cell. And so your red and black are these 2 wires here, which are feeding a voltage across the Wheatstone bridge. And then the white and green, it shows in yellow. I had to make it yellow because you can't show white on white. So I made it yellow and green. That's your output. So there you're going to be measuring the output voltage based on the strain. So a strain gauge, all it is, it's just a little thin film, and it's got a copper trace going across it. It's like a copper wire going across it, very thin copper wire, and it goes back and forth to create a length of wire, because that length of wire will have a small resistance. Now, as this film is stretched, or it's under a tension or a shear or compression, the length of wire here changes, and there's a very small resistance coming out. Or there's a very small resistance seen. So this is why you need to use a Wheatstone bridge, you know, to measure that small resistance here. And if we were to just go and, you know, pass a current through and measure the voltage across here, if this gets warm or cold, the resistance is going to change as well, because that wire is going to shrink or stretch based on temperature. So you can't really measure this accurately just directly. That's why you need to use the Wheatstone bridge. So, and again, here's just this diagram here, and I'll be referring to it in a second, but you've got your excitation. They call it a E plus and E minus. It's just basically your voltage. You're applying a voltage here, and you're measuring the differential voltage across here. And once the bridge is detuned, all the resistances are, or a resistance has changed, this voltage across here is no longer 0, and that is proportional to the strain being applied to the load cell. So here now I'm going to measure the resistances in the on the load cell, and I'll just pause it there. So what I've done, there's my load cell there, and you can see the green and white wire and the red and black wire. So I've just connected alligator clips, green to green, white to white, red to red, black to black, and I'm just going to measure the resistances across the various pairs here. Okay, and notice that's set to 2 kilo ohms scale, right? So here I'm measuring the resistance across the red and black. So here's the red and black. So I'm measuring the resistance across here, which is this pair of resistors in series with this pair of resistors in series, the parallel combination of those. So I'm getting almost 1K. So now I'm going across white and green. So it's yellow, it's green to red.
Recording is on.
I'm going from green to red, which is this resistance, this resistor here, in parallel with the series of this resistance, this and this. So this in parallel with these 3 resistors, and I'm seeing 748 ohms. Same thing for white and black, which is shown as yellow here. So I'm seeing 747, same resistance. So now I'm going to apply a voltage of plus 5 volts, and the white and green are going to be connected to my voltmeter. And I don't know if you could see it, but the scale there is set on millivolts. I think it's 200 millivolts. Milli, not volts, so that's millivolts. So it shows 0 right now because the bridge is balanced. There's no strain, and all the resistances are equal. So the voltage across here is 0. And I'm showing that's 5 volts feeding the bridge. So now I'm going to apply a strain to the bridge, to the load cell, and you can see I'm getting a small voltage. I'm seeing a small voltage across the output. And just basically a few millivolts, very, very small voltage. So now I'm going to apply a known weight to the load cell, and we're going to see what happens. So this can is full of water, and it's coming out to be about 600 grams. I attach it to the load cell, and I'm going to hang it from the load cell. And I know Kevin is probably yawning because he deals with these strain gauges all the time with his equipment. So there I've got it hanging down, and so that's the load cells being deformed. And so I'm seeing about 2.1 millivolts on the output there. And it's minus because it depends which way it, whether it's in tension or compression, right? So if we go on from the video, we look at the resistances I measured, 997, 748. So I got 997 with, for example, R2 between red and black. I got 997, which is R2 plus R4 in parallel with R1 and R3. And the resistance white and black, which is these two, it's R4 in parallel with R2, R1, and R3. So R4 in parallel with R1 plus R2 plus R3. But if R1, R2, and R3 and R4 is equal, then you could do a little bit of math, and you come up with R is 997 in the case of the red and black. And for the white and black, it's coming out to 997. So in fact, all resistances are the same, are in fact the same. And so for my load cell I have, the resistance is 997 ohms. So I only have a couple more slides and then I'm done. So from the video, we measured V out was 2.1 millivolts for 600 grams. It was negative, but ignore the negative sign for 600 grams. So if the voltage is 2.1 millivolts for 600 grams, then it's 3.5 microvolts per gram or 0.286 grams per microvolt. So for example, if the V out was 0.5 millivolts, then the weight applied to this load cell is 143 grams, which makes sense because 0.5 millivolts is about a quarter of that. And so about a quarter of that is coming out to about 143 grams. So in this case, measuring 2.1 millivolts and 0.5 millivolts with a microcontroller, you can't do it. It's just too small. You need some kind of amplification. So there's a chip called the HX777 amplifier, which has embedded a 24-bit ADC. And this is by far the most popular chip used for digital scales. And there's a breakout board you can get on from China. It costs a couple bucks. I think I got 5 of them for a few dollars. They're not expensive, but you can see it's broken out for the excitation, for the voltage to the Wheatstone Bridge or to the load cell, and then you've got 2 pickups for various cells. So here's a block diagram of the chip. You can see the load cell here. You can see the output coming out here on these sides here. The output's going in. It's a differential input into the chip in A plus, in A minus, which is just the differential input, and you're feeding a voltage to the excitation, the E plus, and E minus is just ground. So this circuit up here is just a bias, a way to set the voltage to the load cell, and there's a formula of how to do it. And for the board I have, this is what it works out to be. It's 1.76 volts I'm feeding the load cell. Here's a schematic of the of this board here, and it breaks out all the various components needed to make it work. Where am I? Okay, so then I thought, okay, you know me, LT Spice. I thought, okay, let me do up a bridge, a Wheatstone Bridge in LT Spice. Here's my excitation, E plus and E minus. Here's my sense, S plus and S minus. And here's my voltage, E plus, E minus, which is just ground. And I put in a resistance. Instead of changing all the resistances, I just changed one. Okay, so I make some measurements. I'm going to be talking about measurements when I go back, when I talk about down the rabbit hole. And so I'm measuring the average voltage. This is all DC, but I'm measuring the average voltage of S plus and S minus. And then I'm measuring the difference between them. And then I'm applying a gain. Oh, sorry, you know what? I didn't talk about inside the chip here. Sorry, I missed this. So there's a mux, that where you can mux between the 2 inputs, the in A and B, and that's controlled by I squared C. So you got an I squared C interface, and you could tell this chip, okay, I want to read the B channel or the A channel. That's fed to a variable gain amplifier, PGA, and it's got 3 different values of gain. So it amplifies the input coming in. Then it goes to a 24-bit sigma delta ADC, which is measuring the differential voltage, converting that to 24-bit value, feeding it back to the microcontroller. So where am I? So here in my circuit here, I've got an analog gain of 128. So I'm taking my voltage difference I'm seeing across here, multiplying it by my analog gain of 128. Then I convert it to ADC, which I'm multiplying by this ADC, which is a 24-bit ADC, and that's just the voltage. I'm feeding it from here, 1.76 volts. So that's my resolution that I'm getting. So I multiply that value by my ADC, and it's giving me my digital value. And then my grams is I got my gain factor, and that is going to convert the voltage, that ADC value to a weight. And here you can see the outputs. There's the S plus, S minus, and you can see it's a very small difference between the 2. Here I'm plotting it, and I've got a cursor. You can see it's 2.25 volts, and my calculation is showing the difference is again 2.25 volts, so 2.25 millivolts. And I'm doing the various multiplications, and it's coming out to 600 grams. And I've got this SF just to show you how I arrived at that 457 value. If I take my ADC value, divide by 600, which is the weight I applied, then I get 457, which is this value. That's my gain. Anyway, I just monkey around with LT Spice. So I've just got a couple of slides here, 2 more slides. I'm just going to talk about how you can measure SWR with a Wheatstone Bridge. And I think this will probably be of more interest to you guys than measuring thrust. So in this case, we assume the load is a purely resistive load, because I think if you get any kind of a complex load here, any kind of imaginary, you've got either capacitive or inductive, this probably won't work as well. But if it's purely real, it'll work really well. And you can see you have 2 voltage dividers. So you've got your RS, your source impedance coming in, your Zin is RS, which I set to 50 ohms. And so I'm feeding it here. And you can see this is 2 voltage dividers. Here is 50 and 50. And here's 50 and my RL. Now, if RL is 50 ohms, then the difference between here should be 0. So in this simulation, I'm changing RL to go from 10 to 100 ohms in steps of 10. And I am measuring here the difference between these 2 voltages here. And as you can see, sure enough, at step 5, which is 50 ohms, it's 0. The voltage difference across here is 0. So that's, and you can see the voltage is ramping up on either side. So that's giving me an indication that my SW is R is off, right? And then you can add in a detector to the circuit here, and you could measure the voltage here. And a lot of times I've seen this circuit here, they've got a meter. And that meter, I guess it's like a dip. Once it goes to the lowest value, you know you've matched R in, Z in, and Z out. But again, I think this works well for real loads. I don't know how well it'll work if Z out has got any complex, any imaginary components. I don't think it's going to work very well. But here I'm plotting the difference between V1 and V2. And again, at 5 volt, at 50 ohms, you could see the value is really small. It's, what's that, 1.9 microvolts. And here I'm measuring VSWR, which I'm just measuring the RMS value here with that statement there. And plotting it here, and you could see at step 5, it's the minimum. It's the smallest value. And if you plot these values here, you could definitely start seeing a dip, like a SWR dip. The reason why it's here, it's because I stop at 100. If I went to like 200 or 300, this would climb back up, and you'd get a nice parabolic curve. So that's it. Any questions?
Yeah, Dave, I'm curious, did you, I guess you probably didn't, otherwise you would have likely mentioned it, but I'll ask anyway. Did you try adding a little bit of capacitance or inductance to the output? No, I didn't. I just did actually that SWR circuit. I did that about 2 hours before this meeting. Oh, that's good that you retired then. Yeah, you know what? I've been thinking about it at the back of my head. How would this work for with SWR? Because I've seen circuits using them, and so I thought, okay, let me play around with LT Spice and see how that would look. No, that's good. No, that was a lot of information in there, Dave. Thank you. Any other questions or comments for Dave?
Just makes me want to use LT Spice more.
It's a great tool.
Well, yeah.
Okay. I guess, Wayne, you're all set to go. Actually, before we go to Wayne, Dave, I wouldn't mind seeing, I guess maybe later on, another time how you're doing all that thrust setup for your motors and your planes and stuff like that. Okay, Wayne, whenever you're ready. Still muted.
There you go.
Yeah. Coming through here, Wayne. Not sure what's going on. You were fine earlier, but we've lost your video as well.
Checker, you will find. Sorry.
Okay, you're back on board.
You lost my video.
Yeah, there, you're back now.
Sorry. So just a minute, I bring it back up.
Yeah, you just got a lot of time. Got a lot of lagging going.
Right. No answer. Okay, look.
Maybe go out and come back in again. Maybe.
Yeah, I'm seeing that on my side. It's showing red. Right. Hang a sec.
Yep.
Can.
See when he comes back in. I know our last meeting we had a lot of trouble with it, so it was good to see that this meeting we weren't until until now. Oh, we've lost somebody else now.
Whose clock is ticking? I thought I've got a clock in my office and it's really loud.
Yeah, I bugged you before too.
And people complained about it, but I'm hearing someone's clock.
That's mine.
Okay, can you hear me now?
Yeah.
Yeah, good.
Okay, so what I've got is a transistor checker that you can find on the internet. They go for, in this form, without the container, the box around it, they go for about, I don't know, 13, 15 bucks. 30 bucks if you wanted to try any of the, you know, electronic places, eBay, a design that came around, and I think it was 2009. Project made it, the first version, and it was taken over by Carl. Allow you to see a BJT, a MOSFET. It'll tell you if it's NPN versus PNP and that sort of stuff. And it gives you a few of the values that are significant for the various types of instruments that it has. Have to do this.
Starting to lose you again, Wayne.
You'll see the screen because as soon as I turn it up, it lights up. Okay. Why don't we just call it? I'll try this. I'll try this again next time.
Okay. It looks like probably maybe a bandwidth or something. Dave had a good suggestion as what the problem might be. Somebody gaming in your house. Yeah.
My camera.
No, it looks like we lost Wayne completely now.
Yeah, if you go on, like in your, if you look at the little pictures, the little thumbnails, there's a little bar chart in the left-hand corner. If you hover over it, it'll tell you the connection and the bit rate and packet loss. And I was seeing on the connection, he was getting some packet loss.
Yeah. Yeah. Okay. Does anybody else have anything? This was actually what we started to do was like what gadgets that you may have in your shack that that you find quite useful and whatnot. So we'll try and make that a bit of a regular segment. So going forward, if anybody has something they would like that they find quite useful around the shack, just print it up and let us know. We'll try to make it a regular feature. Well, it looks like Eric, you got something there, Eric?
Can you see that?
Canadian license, is it?
Nice try. Nice try. No, you can't see that. That's really bad. Never mind. Never mind. So I want to build a 25-watt amplifier. Anybody have any suggestions?
Yeah, get a Canadian license.
I want to build a contraband 25-watt amplifier.
Is that Eric? Is that for audio?
No. Just for amplifying QRP radio.
Oh, good luck.
No, there's lots of there is a lot of amplifiers out there. The Indian site that works with Fairhand on his BedX, they were given permission to build a popular amp in the States, and they're selling it quite inexpensively. And I think you can get like 40 or 50 watts out of it.
Oh, this would be a kit you're talking about, right?
Yeah.
Oh, okay. All right.
There's a bunch of YouTube videos, Eric, that shows people building that kit, and they've got measurements and how it works and stuff like that. Just make sure you got to have a really good low pass filter at the end that's going to be able to handle that power.
Does the wattage, the number of wattage, the amount of wattage increase the complexity of a amplifier circuit? Sorry, basic question, but, or is it just the component selection?
The major thing is drive, Eric, because you can't go from a really weak signal to a really huge signal. You have to go and you have to amplify it, stages, right? And so a lot of those big wonker amplifiers expect you to have a big wonker of a signal feeding it, right? In general.
You can only double a signal or something like that. Or
yeah, it's dB gain.
It's dB, right. Yeah. So there's only so much dB gain per each stage. So
yeah.
Okay. Well, maybe I'll start smaller, maybe a 5-watt amp.
Hassan, you got a question, comment?
Yeah, that's, I think what you said is correct, Dave, but I also, can you also just not increase the voltage, and then you get as much gain as you want?
Start getting a distortion, or?
Sure you can. If you could get a 50-volt power supply or a 48-volt power supply, sure. But then you're probably going to melt. It's going to drive a lot more heat loss because it's VR, right? Like the drop across the MOSFETs. You're driving more current, more heat coming out of them. So you may even melt the amplifier. I don't know.
But that could actually, if with right component selection, you put a good heat sink on it, you might actually have a simple one-stage amplifier that could do that, maybe.
Eric, I just pasted the link to that Indian one.
Okay. All right, thank you. Yeah, I was going to ask you for that. No, my main reason is that my NFED can handle up to 25 watts, and I figure I've got, a number of QRP transmitters and all that, but, I'd like to, increase the maximum, output that I can from the antenna. So that's kind of my aim, but.
Eric, why don't you try it? Because, yeah. You're a home brewer, so most people will try to build practical amplifiers that work on 12-volt supply and stuff or whatever. But if you want to go extreme, then you might as well try something that's high voltage.
Yeah, go really extreme and use valves and put 600-volt DC onto the finals.
Yeah.
All right.
Well, we were talking about 2 projects off and on over the years. Maybe one day.
Well, if you did use valves, could you use transformer coupling and get the voltage you need?
It gets tricky with RF.
Okay.
Okay. Thanks for the input, guys.
Okay. Any other comments?
Yeah, I was just typing in a comment to Ken's that WA2EBY amplifier. Yeah, Ken, there's FAR circuits. If you go to FAR circuits, you could buy the actual PCB board from Far Circuit, because it was based on what's a QST or QEX article that was written years and years ago. And Far Circuit sells the boards. I bought one when I was at Dayton. And Kits and Parts, Diz sells the toroid kit. So you get all the toroids and all the capacitors and everything to build the amplifiers. And all you got to do is supply the IRF 510s.
The only problem is I don't think Far Circuit's mails to Canada.
That's okay.
Yeah, I got mine when I was in Dayton, Ken, because they had a booth there. They had a big tent, and I went in and I probably bought about 20 boards from
yeah,
different boards.
Well, this Indian kit, I think it comes with pretty much everything on it.
Comment, Michael?
Yeah, if Far won't ship to Canada, just use cross-border pickups.
Right.
Yeah.
Right.
Yeah.
That works.
I see Far Circuits has a MouseFET 40-watt amplifier, double-sided PCB. What is a MouseFET?
How about a MOS?
MOSFET.
Yeah, MouseFET.
MouseFed.
MouseFed. Yeah.
Of course, you can always take up etching or milling or style building your own boards too. You know.
Right. I could make my capacitors from scratch, and I could grow my own wheat. But
hey, a true home brewer! Yay!
Any other comments? Somebody's got to say, "Oh, that's you, Michael." Or you got another question, Michael?
No.
Oh,
That's it.
Okay. Ken?
Since Wayne has got to put his presentation on, I could do my ham bio if we've got time. It's up to you guys.
Got time?
I got time.
Yeah.
You all got time? Okay. So I'll do that. Okay. My venture into electronics started around 72. I was born in 58, the oldest of 5 kids in Winnipeg. My dad was an electrician. Around 72, 73, 74, I happened to be wandering around in the basement looking to get into trouble. And I noticed my dad had old TVs that were burnt out, radios, record players. And I noticed the circuit boards inside and what all these little doodads were. And he also had a collection of soft cover electronic books. And that's how I got interested. I picked up one of these little books, and most of it was way over my head, but I still found it interesting. I kept on going, and I started taking resistors, capacitors, and everything off the boards and throwing it into a little box. In Winnipeg, we used to have the Winnipeg library system used to have a mobile home that was a library, and it would go to a different place in the city every day of the week except for Sunday. And ours was on a Saturday. And I used to go there every Saturday, and they had a well-stocked ham radio section. And the good thing was nobody knew what ham radio was, so I had those books signed out for weeks on end. And if I wanted to keep them again, all I had to do was go back to the bookmobile, sign them out again, and I had them for another 4 weeks. So they just kept on going. One of the books was the Awrl Handbook, and that's where I started reading into everything. This is around 1975. One of the colleges there, one of the clubs coordinated with the college to put on a basic course. And the good thing back in those days is it was once a week. I think it was a Monday for 6 months. And they would spend the first hour and a half on electronic theory and the other hour on CW practice. So that's how I ended up getting my license. I wrote the exam. I think it was in '77, and I got a total of 95% on the exam, and that's including 5 words per minute. At the same time, I was in high school in grade 12. The high school had an electronics course, so of course I was king there. And the teacher admired me because I already knew a lot of stuff ahead of time that other students didn't know about. These guys were experimenting with little kits. Meanwhile, I was fixing a color TV in the shop next door. So that was my first actual electronics repair. And it was a color TV from home. It had a bad focusing diode. I went down the street. I bought it for $1 and brought it back to school, put it in. I forgot to discharge the tube, and I was sent across the room about 50 feet. And that was my first learn not to do TVs anymore, at least the tube type. Back in '77, Heathkit opened a store in Winnipeg. I think it was September 1st. Guess who was first in line when the store officially opened on a Saturday? Yeah, it was me. They had a all-band receiver, CW-SSB. It was called the HR-10B. And I think I paid at that time $80 Canadian. I had that thing built in 4 days. And I happened to join a club there. I picked up an old DX60B transmitter, 100 watts or whatever it was. So that was my gear when I was still living at home. My dad, being an electrician, built me a dipole, a multi-band dipole. So I was active in CW for about a year. We're talking about 1980 by then. 1981, I ended up getting married along with the white picket fence, and the ham radio went down the drain. So I hadn't been active since '82 up until 2008 when I joined PARC, the PARC group. Oh yeah. Let me share. Share. Okay. This is the HR-10B that I bought in '77. Something like this. Yeah, I had this thing built in 4 days. It was there was no pre-built modules whatsoever, except for the mixer coil board and the bandpass board, and this is what it looked like inside. When I first had bought this thing, I happened to write the serial number down in the manual that I had. And when I got married, I ended up donating my radio and my transmitter to a novice that just joined the club. And that's all that I know of ham radio up until 2008 when I just happened to be on eBay looking for something, and I came across Tony Park's Soft Rock, and that's I ended up buying this thing. I was very intrigued by the software-defined radio, and also while I was looking, I happened to be coming across this. It was an estate sale. Very good shape. I ended up buying for $50 US. I also ordered a complete set of tubes, new tubes, from a company in California called Tube Depot. What the strange thing is that the serial number on this one I bought is exactly the serial number I wrote down in the manual back in 1977. Full turnaround. I got my radio back. Unbelievable. So that was quite a surprise. I don't know how I ended up getting this thing. It just by chance. So that's my bio.
That's very good. I mean, that's a really cool thing when you get your original project back that you built it yourself.
Yeah. Well, you know what? I recognized my soldering, so when I opened it up and looked underneath, I could see that it was me that did the soldering because I was so careful. I never burnt any of the plastic on the wires. I was very careful. The thing is so clean. Everyone that I looked at on eBay, like the transformers were all rusted. There's stains all over the chassis. This one, it's just got a thin film of dust on the chassis. That's it. Now, the only problem with the radio is that the dial string is stuck. So what I plan to do is take the front panel off, fix the dial string, and put it back together. And I have nothing to clean or anything. It's got a couple scuffs that weren't there before, but yeah.
Oh, that's pretty cool. I have a very quick story about Heath kit. I built my first kit I ever built was a vacuum tube voltmeter. You can kind of see it over my shoulder there. And anyway, after I finished it and I was working a bit erratic, so I sent it back to Heath kit, which was down in Cookstown or Cooksville, whatever it was called in those days. And anyway, I got the thing back, and I had the technician's report. The technician's report said he found bad solder joints. I was so insulted that in those days it took 2 buses and two bus fares to get down there. And I jumped on the buses and went down there, and I demanded to speak to the technician that insulted me with my soldering job. But anyway, they probably heaved me out. I can't remember now. Okay, thanks very much for that. Ken, any comments?
Did you contact the original eBay seller?
No, I didn't. This guy didn't. No, it was a private estate sale in Iowa or something like that. They had no clue what they had or what they were selling.
Wow.
But it was just like, it really shocked me because when I first gave the radio and the transmitter to the Novus in Winnipeg, I thought I had lost the manual, so I couldn't give him the manual. He said, "Don't worry about it. I could probably get one." And in packing up, moving from Winnipeg to Guelph in 83, 84, I happened to come across the manual. And then, like I packed it away. And then when I found this radio on eBay, I had gone looking for the manual, and I found it. It took me a day to go through, rummaging through everything. And then when I actually got the radio, I noticed on the back, with this radio, you got to check 2 things. There's a 100 kilohertz crystal calibrator plugged in. If you noticed on the when I showed the back with the cover off, and there's also an octo plug on the right side, the back. So I had to make sure those 2 parts were there. But I also glanced at the serial number and I checked the manual, and they matched. What are the chances of getting your own radio back?
Well, that's why you should have went out and bought yourself a 649 ticket at the same day as that. Okay. Well, we're running pretty good here. Let's have I think maybe we'll get into just a quick round table here, and then, well, we'll go from there. Since I'm at the top of the screen, I guess I'll go first. I've gotten back into milling after a little bit of a break there. So I've milled up this past week a couple of boards and whatnot. I did a board of that size. I was surprised. I don't know. I must have hit a real slow setting. It took 4 hours to mill it, but you don't have to sit and babysit these things. You can move on and do other things. So that's the nice thing about the CNC. And just started to populate the boards today. And that's pretty much about it for me, my shack. Dave, you're next up on my screen.
Okay, yeah, I've just been building my test bench, and I built a couple new airplanes, and that's it.
Look forward to the video there. Drew, what have you been up to?
Oh, I've been very busy with work, so nothing much at this point. Like, you know, I've been also planning to make some Hamfest visits, but nothing much has been happening for quite some time now. I think the first one, which I see in the list, is now going to Barrie for the first one. Usually these Hamfests actually keeps me energetic and kind of, you know, to do something, you know, that kind of thought process comes when I go to a Hamfest. So for the last 1 year, there has been not so much. I've been also very low on, you know, what I've been doing as projects. So I need to start building something again. So that's the idea. Yeah, okay. Nothing much at this point right now. Yeah, but I'm looking forward to the summer, and actually got to retune some antennas and things like that. And also, you know, looking forward to buying some more, you know, maybe test equipment and things like that. Especially looking forward to owning one rig expert, which is also, you know, covering up to 600 megahertz. Looking forward to, you know, experimenting with some antennas. That's what I'm looking forward to for the summer.
Okay, great. Well, yeah, Hamfest. Yeah, there's one. I think Perth, I think, has, or somewhere around there, is coming up fairly soon. So I think I'll probably go to that one. Barrie is a little bit farther than I want to go. Okay, thanks for that, Cherry. Drew, how are you this night? Maybe Drew is stuck. Okay, I'll come back to Drew. Eric?
Not much on my bench right now, except a fuzzbox circuit. That's what I was trying to show you here. So it's a one transistor, was it 30? Yeah, 2N3904 fuzzbox for my distortion effects on my guitars.
Well, you know what? I guess talking about an audio circuit on the AF mixers is appropriate.
Yeah, that's true. Maybe I could add some distortion to the you know, CW signal when I.
Yeah. Yeah, I'm sure that would go over well. Right. Speaking of the CW stuff, we did that a little bit on Monday night, and we were talking to Frank with he was sending up QRP power from all the way to his place to Kingston. It was a good night. So if you guys want to try something out, look forward to our first Monday night CW nights. Frank, speaking of Frank, how are you? Don't hear you. Although you don't seem to be muted. No, still can't hear you, Frank. Now you're showing, no. Maybe come out and come back in, Frank. No. Try coming out and coming back in, Frank. Refresh your browser. Maybe that'll work. Okay, maybe we'll go on to Hassan and we'll wait for Frank to come back in. Hassan, you anything on the bench these days?
Yeah, I took out the FPGA and I started playing with Verilog for after a while. So I wrote a SPI adapter It turned out to be a lot easier than I thought. So that's something I've been doing, partly for work, partly for home. I did have a question. I found this device called a Salii logic analyzer. I don't know if you guys have seen that.
The name Salii sounds familiar, but I'm not sure in what way. But
yeah, is that, Hassan, is that open source analyzer? They have the Chinese kits. They got the open source. Yeah, I've run across those. It's a they come in like 4-pin or
not $20 ones. Not that this is the expensive one. It's $600, but it's really beautiful. It's really good.
Yeah, I think Google around, check on the Chinese websites. I think they have knockoffs of that logic analyzer.
Yeah, we're thinking of getting one for work, so I just wondered if anyone had ever actually used these.
No.
Okay. I have the knockoff one, and it works perfectly well. It's $20, so a lot cheaper.
I would buy then.
That's all for me.
Okay, thanks, Hassan. Frank.
Can you hear me now?
Cell phone commercial.
No?
Yeah, go ahead, Frank.
Oh, okay. As I was saying, it's nice to see everybody on tonight, and particularly Simon. Haven't seen you for a while there, Simon. Nothing new on the bench, but this week I did order a kit, and it's the QCX Mini this time. I have the original QCX, and I have the QCX Plus, so I figured I round out the stable with the Mini, and just something to get my hands on and build over the summertime there. So that's about everything that's new on my bench. I enjoyed Monday night CW group we had, and was happy that the propagation was in our favor that night.
You're muted.
Yeah, that was a lot of fun that night, and it was good to see that the QRP between your area and Kingston was working well, and unfortunately didn't have anybody else out from the metro area. Eric joined in from the Caledon area, and but I guess Eric had a little bit of trouble with reception, except for when one of the guys here in Kingston across the riverway jacked his power up to 100, then Eric was able to hear him. But yeah, it was an interesting night with the propagation for sure. Okay, let's see who's up next. Well, Ken, you're next on my screen, but I guess your time's filled with the DCR. Did you have any time for anything else other than sleep?
What sleep?
Yeah, there you go.
Let's see. I don't need no stinking sleep. No, I want to get this DCR completed and get the kits all ready. What I plan to do afterwards is I'm going to start working on this receiver, get it cleaned up and fix the dial cord, change the tubes. And there happens to be a gentleman in the States who does capacitor kits. So I'm going to be, I ordered one. It's a triple microfarad, 20 microfarad, 600 volt capacitor. So I ordered the kit, and I'll be replacing the old one with the new one.
Okay.
And then once that's done, I want to go back to some of the kits that we've been working on as a group. I want to get back to the LBS and get the darn thing built. And I got some other things I want to get built as well.
Okay, it sounds good. I know what you mean by trying to get a project off the bench so we can get out to these other ones. Michael, good evening.
Well, I've been doing a little bit of playing around, not a lot. I have an FT1000MP, and it has one of these BCD connectors on the back, the ABCD outputs. And I've been doing a lot of FT8. And what I want to do is, with FT8, you basically change the frequency by by clicking a button, and what I want to do is make the radio follow. So that's what you do is you connect the radio to a BCD board and with relays, and then you can switch your antennas, which is what I'm going to do. So I started on that. Also cleaned up my shack because I wanted to put an anti-static mat down, which I've got now, and I've been fiddling around with a little bit with the spectrum analyzer and the PARC signal generator, as we were saying earlier. And that's about it. A little bit of cleaning up and getting organized. Anyway, that's about it for me.
You want to come over to my place and clean out my shack?
Yeah, I had to do a bit of a clean up on my shack too, because I was looking for my little tiny drill bits and couldn't find them anywhere, so I was forced to clean up. And I eventually found the drill bits, but they weren't in the shack. My eldest had borrowed it. Okay, thanks for that, Michael. Simon, anything on your bench these days? Some kind of a tube project, maybe?
Yes, actually, I've been playing with a couple of tube projects, an audio amplifier, and then some vacuum tube VU meters of various flavors. It's slow going because obviously I'm still full-time, and work is keeping me pretty busy at the moment.
Oh, very good. Yeah, when you mentioned audio tube project, I was originally going to build a tube guitar amplifier, a nice big one, but in the end, I didn't. Okay, Kevin, good evening.
Hey guys. Yeah, I'm not doing that much, although I've been trying to. I'm actually working on some antenna traps because I want to make one end-fed antenna for like 20, 15, 40 meters. So I got some QRP guys antenna traps that have been sitting in my drawer for about a year and a half now. So this summer I want to try and reduce the number of wire or the amount of wire I have to carry if I'm going to go outside the shack. So well, that's my goal.
Well, we can test your 40-meter trap on the first Monday of the month for CW night.
Well, the whole idea is that it gets me out of the shack. So yeah, I'd have to go somewhere and set up, but theoretically, right?
All right, thanks. Okay, let's see who we got. Get rid of this toolbar down here so I can see who we're talking to here. Ah, Dwayne, good evening. How's things down in Georgia? Well, maybe Dwayne's having a little bit of trouble there. Oh, it's just listening, no mic. Okay, Dwayne, thanks for the message and letting me know. Okay, and Wayne, one last kick at the can to see if you can at least have audio, or what have you been on to the bench?
Yeah, I've turned off my screen. Can you hear me?
Yeah, no problem.
Oh, cool. I've turned off everything. So what I'm doing right now is I've got a project to build a pre-selector. I was thinking of it as the front end for the DCR. And I'm trying to make one that I can switch out segments of the toroid inductors I'm using for the tuning part, and get coverage for the entire 3 to 30 megahertz range. And we'll see how that works out. I'm not quite sure if it's going to work. I have some dual gate MOSFETs. They're no longer manufactured. Bought them from China. Every single one of them is junk. So I've switched to a Casco design, and I'll see how that works. That's it.
Okay, that sounds good. Interesting. Thank you for that update, Wayne. Drew, are you back yet?
Yeah, I'm back. There we are. So I installed in my Yaesu FT920 a panoramic adapter from was it G4 HUP. It's a little board you stick in and allows you to sample the IF. And the idea is you feed that to an SDR and into a computer, and you get a pan adapter out of a radio that doesn't have one. So that seemed very slick. And one of the other members, Carrick's, did the same thing with his FT450 and seemed to be doing okay. So I've discovered that it isn't at all easy. And in fact, I've got so many artifacts showing up on the HDSDR screen that it's hard to find a signal. So it's quite a learning curve to get this thing to function. But I've since discovered that the HDSDR has its own artifacts running in the computer even without an input. So I started to examine exactly what it is wrong with what I've got and seeing if I can get rid of some of the interferences. Some of the interferences were just cheap LCD screens that were in the shack, but other things are showing up I can't quite understand. So it's very hard to find signals, but the idea is to use it as a pan adapter, and it's been a learning experience so far.
Oh, that's what it's all about, this hobby, isn't it? Learning.
Oh yeah,
pan adapters. One of these days, I'm going to get around to getting something set up on my rig too. It'd be nice to have.
Well,
okay.
That's what I thought, and I'm not so sure it's going to work out the way I thought it was going to work out. I know Andrew's dissertation there on our website. What he is describing there, I am finding as well, is that it doesn't work quite as slick as I thought it would.
Mm-hmm. Well, I think Rick has a good go with these sort of things too. So lots of help around anyway.
Yeah.
Okay. Well, that's it for everybody on my list here. So that's great. Thanks for everybody for joining. Any final comments, questions, queries before we?
Yeah, I do.
Yeah, Ken, go ahead.
At the meeting last night, they had brought up the Hamex thing, and of course this year it's not going to happen. What they are thinking on doing is a junk in their trunk setup. I think they have it in the planning stage right now. They got to figure out where they're going to have it. So they're going to make an announcement, and it'd be interesting to see what people want to sell out of their trunks.
Yeah, that'll be good. We tried to do a junk in the trunk, but we got rained out. Did they say anything about the repeaters?
We had a discussion back a little while ago. They had found a location, and it turned out the location was not suitable.
Okay.
They wouldn't be able to facilitate our needs. Edmundo is, I think it's tonight. He's got a friend who's a friend of the mayor of Brampton, and they're going to pick his brain about getting the repeaters up on some kind of site that's owned by the city.
Okay.
For free.
No, I'll do that. Well, hopefully that'll work out. Okay. Anybody else have any other comments, queries? Okay. Well, thank you everybody for attending tonight. Our next meeting, the regular meeting, is on the 20th of April, and so far we have part 3 of the rabbit hole journey by you know who, and I'll have some LT Spice tips. I'm not 100% sure which one it's going to be, but it'll be something about spice. And of course, if somebody else has something else to they would like to present, there's time and room for it as well. Don't forget to look into your shacks for a little bit of interesting gadgets that you might want to show off. And I guess with that, we'll say 7-3, and thanks all for joining us tonight, and we'll see you in a couple of weeks.
Yeah.
Good night, everybody.
73.
Recording has stopped. Can't hear you.
There we go. Thank you for reminding me recording is stopping in a moment. Stop. Yes, I would like